Welcome. I'm Bruce Morey, Senior Technical Editor of Manufacturing Engineering Magazine, and this is another SME Media webinar. Today's webinar is titled, Why You Need a Digital Twin Now. This webinar is a joint production from both SME and Vertex Software. However, the subtitle could really be called How Today's Global Manufacturers Can Stay Collaborative During COVID-19, and we'll discuss what we really mean by that. The idea of a digital twin isn't new. By now, we've been inundated with the reasons why digital twins are business critical and how they impact your workflows. But today's radical global changes make digital twin technology more important to consider now than ever before. John Heller will join me to discuss the shift to remote work and how the digital twin promises to connect disparate teams. Today, we will learn what a digital twin means in today's industry, why companies can't wait any longer to leverage digital twins, and how technology tools such as those from Vertex Software can help you implement digital twins technology immediately. John's extensive experience in mechanical engineering, supplier collaboration, cross-functional relationship building, and procurement activities gives him insight into the best ways to bridge the gap between engineering, procurement, and the supply chain. As product marketer for Vertex Software, John understands and communicates pain points and opportunities in manufacturing organizations. As we discussed before, this is a joint presentation. This presentation will be in two parts. I will introduce some of the core concepts and motivations behind the push for digital twins, and John will get into more detail about his company's specific solutions. Now, before we get started, I'd like to outline how the webinar will proceed and a couple of housekeeping items. On the right side of the screen, you'll find a question and answer box. If at any time during the presentation you'd like to ask a question, please type it in this box and send it along. These questions will be answered at the end of the presentation. Should we run out of time, the questions will be sent to John or I, and you'll receive an answer by email. Should you experience any difficulty during the webinar, such as a blank screen or a lack of sound, please use the Q&A box to alert us, and we will respond individually in writing with a suggested fix. That brings us to the final housekeeping item. Should you experience a difficulty such as this, the presentation will be available in recorded form at about 4 p.m. Eastern today. You may then watch the recorded version of this webinar at a time and place when you have more bandwidth. You may also watch the webinar as many times as you wish to catch details you might have missed or for any other reason. All you must do is sign in again using the credentials you used to join us now. You may even share those credentials with colleagues who might benefit from learning more about this topic. Now, let's get started. Digital twin, why do it? Before we get into what digital twins and the challenges of digital twins, let's first discuss motivations. Why would you create it, invest in digital twin technology? The gap between what a design intends to do and what happens in the real world might be the fundamental issue in engineering, design, and manufacturing. I will argue in reality, of course, ever since the invention of the computer and CAD replacing paper drawings and physical bucks, there's been something of a digital twin in the sense that there was a digital representation of what a product is supposed to look like, and with CAE, how it was supposed to function. However, every solution brings awareness of new problems. A CAD model is static, and as was quickly realized back in those days, almost always varies from reality in big and small ways. Thus the terms as built versus as designed. Same with CAE models that depend on knowing forcing functions and material properties that may be unknown or even unknowable in the real world. The real key is feedback is missing. So one of the promises of a digital twin is to compare what you intend with what is actually happening. The advent of cheap sensors and high bandwidth data networks is enabling this vision, along with a lot of other technologies that John from Vertex Software will also discuss. The concept of the digital twin can be compared to or even the equivalent of cross-reality environments or co-spaces or mirror models, things here I'm sure you've all heard of. Like I said before, the goal is to synchronize part of the physical world with its cyber representation, an abstraction of some aspects of the physical world. And the truth is we just can't do it all. Of course, you have to pick and choose, and I think John will get into some of those realities during his part. Like I said, you have to pick what parts of reality you want to mirror that is vital to your design working in the real world. You simply can't measure everything or model it all. There have been, in reality, some attempts to close this loop. In the automotive world, for example, quality information systems built on customer surveys and repair shop records kind of give you the feeling of what a digital twin can do. I will claim that the promise of a digital twin is more data from the real world and not subject to interpretation or at least human error in the collection. So what is it? I've kind of alluded to some of this, and I can tell you more of the history of what it is than what it is in general. But as you can see, the general sense of it is that it's a digital replication of a real thing or a fleet of real things that includes all the product information that you need, including the physical dimensions and the vital functional performance. It is generally accepted that the concept and practice became prevalent in the aero engine world as engines became more like lease items with guaranteed uptime hours. At least that's from a journalist's perspective, since that's when I first learned about digital twins when I was covering these groups, especially General Electric. In fact, General Electric is often cited as one of the first, but the concept I found is often traced back to around 2002 or so. And the definitions are definitely ambiguous. For example, Wikipedia, which is not necessarily a good source to be cited, but it does describe some of the issues with it. Wikipedia lists 7 different definitions of what a digital twin is. While it is easy, like I said, to think of CAD models as a digital twin, most definitions go well beyond that. Some talk of configuration, as I discussed before, as built versus as designed. The key, I think, which will be reinforced by John, is data from the real world used in a digital model to provide insight. I'll explain this in more detail in 2 more slides. For high-value objects, this means the actual serial number of each instance tied to a central database, where each instance may vary from the CAD model. Think of $100 million airplanes or aircraft engines where minor modifications or field mods were necessary to keep it running. Or an airplane engine that is certified for use in Asia, for instance, versus use in Europe. Others talk of functional twins, using CAE combined with measured performance data to understand how real-world objects may operate. This is especially true for how they might fail, such as fatigue models tied to markers of future performance, so workers can schedule maintenance when needed. And this is one of the often cited uses of digital twins because it is quite a bit different than planned maintenance, or PM. That sort of guesstimates when you need it. Using the digital twin uses actual data, and that may vary from a planned maintenance schedule. The key is data, and collecting and using that data from the real world to update the digital twin. What is enabling this concept is, again, cheap sensors, a way to quickly move the data, tied with AI and machine learning makes sense of that deluge of data. So COVID-19. The extraordinary pressures from the COVID-19 are making the use of digital twin technology even more important, if not more prevalent. And certainly it highlights the use of what could be digital twin for the future. This is a picture of the Hamburg airport empty because of the late pandemic. However, the real question as we move out of the pandemic, and we will, I am confident of that, is how much of these new ways of working will stick. We're kind of already seeing this. It reduces physical visits. It reduces the need for physical visits, even as physical visits are becoming more difficult to accomplish. And again, we can predict what can happen in the future. So another aspect of this, I'm sure many of you already know or are familiar with this data pyramid, where at the very bottom of the pyramid is a wash of data that is often so much that you simply can't make sense of it. This has been applied to a varied number of things, from computer vision to stock market analysis. You go from data, which is a lot of points and a lot of data elements, to information, which is fewer data elements, to knowledge, which is even fewer, to making a decision, sometimes as much as just yes or no. Funneling and organizing that data up into decisions is what the digital twin is all about. And clearly down here at the bottom where it says data, that's where the digital twin technology is going to be applied. especially useful for things like if you're useful and or familiar with quality assurance type concepts. The idea of common cause from special cause issues in the field. I really think that digital twin data and the use of digital twin can really help engineers find those common cause issues in the field. You can read some of the other things here. You can work remote from your global team, aggregate performance data from the field, provides monitoring and diagnostics and prognostics. And as I said before, the digital twin helps organize all that data and get you on that journey toward making a decision up the pyramid. However, there's issues. Some of these issues really can be boiled down into two different kinds, organizational and technical. The technical, we could talk about all day long about the sensors and Internet of Things and different kinds of protocols. But there's always, when you introduce any new technology, there's always an organizational change that has to be addressed as well. Implementing the digital twin has these twin challenges. As in many human endeavors, their organizational challenge may be the more difficult. What are often termed as information silos are still prevalent in today's organizations, and while breaking them down to facilitate more uniform information sharing is generally a good thing, many people have a hard time making that change. And frankly, when I first started my professional career coming out of college many decades ago, I heard people talking about we need to break down the information silos, and 40 years later, people are still talking about it. So you can see how hard it is. Information is still spread around CAD departments, CA departments, quality information departments, and even PLM and IT departments. And don't forget that the phrase, just ask Bob, is sometimes the most reliable source of information. That tribal knowledge invested in all the Bobs and Bills and other people in your organization, you have to be able to tease that out of them and put them into some sort of organized format. Changing these organizational habits will be difficult, and it needs a top-down approach. The technical challenges include choice of protocols, technology, and how fast and how big an organization wants to go. Both of these will be addressed by John at Vertex Software. So now, let me hand it over to John to discuss further. John?
Yeah, thank you, Bruce. And hello, everyone. And again, as Bruce mentioned, John Heller with Vertex Software. And have spent, prior to joining Vertex Software, 18 plus years in the manufacturing industry across many different departments, across many different teams, and I've experienced firsthand the difficulties that it comes when actually taking theory and making it practical. And Bruce did a very good job of laying down the groundwork here for digital twin. But I can't help but think, Bruce, that for many individuals, the idea of implementing a digital twin, this concept of digital transformation, digital thread, is all overwhelming, perhaps. And in this time when individuals are looking for easy ways and quick ways to shift their models a little bit to this remote environment that we might be living in, as well as attempting to stay connected, attempting to move business forward, I think the ideas of digital twins and digital threads are intimidating. And I know the previous company that I came from, it was talked about for years. And people, we talk about organizational barriers. People tended to be, it's easy to say, right? This idea of digital twin, digital thread, digital transformation. But great, what does that mean for the practicality of my daily process, my daily workflow, business issues that I'm trying to solve, trying to maintain connectivity with customers, trying to get a project done in time, trying to make the best decision that I can with the information that I've got, being up against perhaps a timeline where, the temptation to work outside of a process presents itself and workarounds creep in, and before you know it, those workarounds become status quo. And I would just like to encourage us all and our audience today to always bring it back to the practical roots of, okay, so what? So what digital twin? So what digital thread? How do I make this into something that I can use now? How do I maintain business continuity? How do I stay connected? How do I not let product quality suffer? How do I accelerate timelines, perhaps as my competitors are struggling? Let's just be honest. Not that we're looking to capitalize on somebody struggling, but in the competitive environment that we live in, go-to-market strategies, the time you're able to get something out the door, the way you're able to connect with customers becomes vitally important. And that's how this concept of the digital twin can be now taken into a practical standpoint of addressing these daily tasks, these daily collaboration issues. And so here at Vertex, we've heard from many of our customers, we've heard from individuals in academia, individuals who do a lot of analysis within this PLM space, within this digital twin space. And the one thing we keep coming back to is the inability to really connect the data with the people, with the workflows that need it that in order to make their decisions. And to be clear, engineering groups and companies have invested a lot of money into these initiatives, into PLM methodologies, into PLM tools, PLM softwares, and for the most part, engineering departments, if we think about the engineering departments themselves, they're set up quite well to be able to develop 3D models, to initiate that sort of digital twin source, and they're able to get it to perhaps a fellow colleague or somebody in a different part of the world who has a similar software, who the company has invested into adequate GPUs, adequate hardware to be able to consume that information. And so those workflows perhaps are set up well, and companies have made appropriate investments. But we all know that not everything is done within engineering. I'm an engineer, and so I'll be the first one to admit that while engineers like to think that the world that they live in is functioning just fine, there are other departments and functional areas outside of it that need this information. And I, for one, was one of those individuals who would constantly probably annoy my engineering colleagues, always asking them, hey, can I get the data? Can I get this digital twin representation, if you will, in a way so that I can pass it on to a supplier or pass it on to a potential customer, or we need to get it out to the manufacturing floor so that they can view it, make decisions, we can collaborate on it. And so from a positioning standpoint, Vertex is not going to replace PLM. We're not going to replace your CAD investments. Where we see the need and where we are supporting workflows is the ability now to get that 3D information out to other functional departments, such as your sales and marketing team, such as your service departments, getting that digital twin out to the manufacturing floor so that design for manufacturing, design for assembly decisions can be made, work instructions can be put together, GD&T and PMI, and we'll get into this here in a little bit later, can be made. And so that's really the core of what Vertex is enabling, is connecting teams to that digital twin. And if we talk a little bit into some practical ways that a digital twin can be used for manufacturing, and it certainly, as I'll demonstrate here in a little bit with the Vertex software, we all know that connecting visuals to your data is where the benefit really comes. And first and foremost, though, that data has to be freed. And so once that data is freed, we can see here that it enables companies to perhaps, let's imagine with me, if you will, in this time of remote work where companies are facing human-to-human safety factors, maybe more so than in the past, and not just now human-to-machine safety factors, but imagine the ability to visualize an entire factory and to be able to connect that visual factory, if you will, to your systems of record, and to be gathering the data from those IT sensors or those IoT sensors as they're coming back, and to be able to say, see machines that might be faulting out, see machines that perhaps are not as efficient as they could be, and to be able to specifically then from a remote standpoint perhaps see that, and then be able to address the issue in a very quick and a very targeted way. I can remember as well, first pass yield on a manufacturing line is when it comes to end-of-line testing perhaps is very key for companies, and being able to adequately get insights into their quality, being able to understand where the defects are, and certainly visuals are a key piece of that digital twin as well. And as I mentioned earlier, being able to provide a feedback mechanism and then a collaboration mechanism where your shop floor is able to understand GD&T and other tolerances that are needed, as well as certain PMI information, and be able to either provide feedback on that and improve the overall process, or to be able to understand better how to make something and to cut out some cycle times in there. But again, really that struggle of being able to find an easy-to-use interface from that standpoint. Additionally, companies might be looking to understand how they can be lean in their manufacturing processes during this time. And so understanding what perhaps a full factory walkthrough could look like, where you've got the ability to insert yourself into a 3D representation of your factory and understand where things are located, get an idea of perhaps key work assembly and disassembly procedures, spacing, being able to optimize that from a standpoint as well. Then, as Bruce mentioned, we often think about as well the different variations from an engineering bill of material and moving into a manufacturing bill of material, an MBOM, or moving over to a service bill of material, an SBOM, and the different things that change as those iterations are made. And not always is the digital twin perhaps able to keep up with that, again, through either difficulty in the technology that a company might have, or the admin time that's required to prepare that. Oftentimes, visuals can become lost, with just with visual things or information only being reduced down to letters and numbers on a page, which can be confusing, perhaps, to an individual about what are those defective parts, and what is the part number perhaps that I need to verify against what I'm actually seeing here, and being able to address it quickly. Then, as we think about another practical way that a digital twin can be used is in the realms of service and quality. Certainly, we see that service, field service, warranty, aftermarket are traditionally areas that perhaps struggle to get the digital twin in a way that helps them do their jobs better and can connect with customers. I've heard of many companies flipping through a 3-ring binder on a repair manual or some type of a service manual, and they're looking through static 2D images of perhaps a work instruction or an exploded view, and they're trying to make sense of what they're seeing in the real world with some type of a paper trail perhaps there. But however, imagine, the practicality of being able to have that digital twin out in the field. That field service individual gets a one-to-one representation and is able to quickly diagnose issues and perform replacement ordering in a much better way, improving the customer experience. Imagine a better way of performing technician training and being able to step through a repair instruction or part replacement with high quality 3D geometry in such a way that engages the users and helps them learn and improve the end product. We know there's always an issue when something perhaps goes down in the field, and then needing to understand part numbers and doing part traceabilities in order to be able to proactively address root causes and to be able to get perhaps that batch of parts segregated and a new batch ordered, and then that part updated throughout perhaps your service bombs generating from your engineering bombs. And so we see there's many ways that a digital twin could be used in very practical ways to aid manufacturing companies, not only in the quality and in the manufacturing, but as well in their service and in their end quality aspects of that. So what I would like to just show now briefly is a very practical way that Vertex is enabling digital twin collaboration. Not again just limited in these areas of manufacturing and service, but as we think about many other use cases, perhaps a digital twin to connect customers with a product configuration aspect, or digital twins to connect procurement departments to their supply chains on should part costing versus actual part costs and assembly costing. Really the possibilities are endless, but the key thing is freeing the data, getting the data off of heavy graphic-intensive GPU hardware, off of expensive software, and really putting it out in a spot where others are able to utilize that digital twin for collaboration, improvement, and innovation. So I'll now just share my screen and jump into a brief demo of how Vertex is enabling companies to immediately begin utilizing the digital twin for collaboration. And so you hopefully now will be seeing a login screen where you will find the entrance into the Vertex platform. And as you can see here, it's just a web-enabled browser login. No software that I'm accessing off of again, I'm just on a very basic Mac laptop right now running off of the internet. And so I can come in here, and as you'll notice, we do provide single sign-on availability to make it very easy for your IT departments to structure this in a way that enables quick access, secure access. We'll get into that here in a little bit as well. But so once the user is brought into the Vertex platform, you'll see here this basic page where all of your 3D models, or digital twin representations, if you want to call it, can be brought in. One of the things that we hear consistently from customers and those in the field is, okay, that's great, you say freeing the data, but I currently have to do a lot of data transformation in order to get a digital twin out to somebody outside of engineering. Vertex eliminates those unnecessary and administratively burdening workflows by providing very simple ways for you to get your information in there. One can be just quite simply through an import. We're able to import in all the major native as well as neutral file formats in their existing formats. So you don't need to convert files. You don't need to reduce down files. We additionally provide APIs into your CAD and PLM systems that can automatically sync in data on a predetermined script as you would so determine it that works with your company. But again, a key differentiation point when we see about struggles that companies have in getting their information out is really this data transformation. And it's the barrier of not having the right software and not having a powerful enough hardware to be able to do it. So quite simply, we've got a landing page here that, and again, as we mentioned, collaboration being a key piece of that. And one of those key areas of collaboration that Vertex is enabling is what we call around a Vertex Story. And a Vertex Story is a collection of snapshots taken from the engineering bill of material. And as you can see here, as I'm moving this around here, these snapshots are not your typical 2D snapshot or a screenshot, if you will, but rather a fully immersed 3D representation complete with the bill of material for what is currently being viewed within this viewer window here. And so let's imagine that in this case, a individual put together a series of snapshots to resolve an issue where we've got some gears overlapping here. And so we're able to come in and put in some comments here that help us understand exactly what the issue is, as well as the bill of material, and it's fully interactive. So if I want to click here in the field of view to see what part that is, it's going to highlight it. Over here on the right-hand side, I can perform a couple of different operations as well to interact with that. But again, if we think about perhaps traditional ways right now of having to screenshot stuff to put it into a PowerPoint, or creating a separate orphaned file and putting it out on an FTP site where security could be suspect, where you're not tied directly back to the true source of data, here the Vertex Story is a very powerful way to be able to collaborate on issues. If I look at another one, we see here we've got a couple of different perhaps configuration options that we want to collaborate with a customer on. This here example is a supercar where we've got a couple different rear spoiler configurations, as well as a couple of different wheel configurations that a customer might want to evaluate. Additionally here, and to illustrate the power of the Vertex platform and enabling digital twin collaboration literally on any device, here I've got a fully configured, full modeled submarine. As you can see here, I was able to open that and to get down into as much detail as I want to, again, with the bill of material associated with it out here. I'm able to now collaborate with individuals perhaps out on the manufacturing floor or with a customer. We want to understand, do we have enough clearance coming down this aisle here? And we want to, again, be able to take another look and another view of that as well here. So very powerful ways of collaborating with the digital twin. And if you allow me to just briefly describe how we're able to do that, coming back to, again, the ability to be able to leverage the technology that we are able to utilize with being a cloud-based software. Again, no software, no download needed. We're able now to be able to take that information that is brought into the Vertex platform, and utilizing multiple parallel cloud servers, we're able to distribute that data. And then when a user calls up that information on whatever device, whether it be a laptop, whether it be an iPad, whether it be a phone, we do all of the heavy lifting in the cloud. So we pull all of that information back together. We render and composite it in the cloud and stream it down to whatever device you need. Again, with fully interacted 3D visuals and bill of material, as you can see here, associated with that. That's what enables us to truly scale up both in size of model and in number of concurrent users, whether they be out, in the middle of the field with a piece of machinery that's just broken down, or they're out on the shop floor trying to diagnose why a part has gone defective. Literally being able to access that digital twin on any device and to be able to collaborate in a meaningful way with others in order to address any type of issue. And so let's imagine very quickly here that we put in a new engine. We've got some rear suspension problems now presenting themselves on the supercar model here that I've got open, and we want to be able to find that information and quickly package it in a way that we can make decisions and move things forward. And so we're able to find parts either by searching through the bill of material, as you can see here on the left, and searching actual names of parts or assemblies, or we're able to perform different searches based off of the metadata properties that are brought in here. So if I just perform one filter here to kind of show you how that might work. We know that we've got a rod assembly in the back of this supercar that we want to take a look at. So here I've been able to quickly create that filter. Now I just want to be able to quickly pull just that part up and understand what that looks like. So there I've got that rod assembly pulled up. Now I want to be able to perform some various types of interrogation on this model and pull back context and start describing exactly what I might need resolved or what the ask is for my collaborators. So I might come in here, I might add a section to this part. Let me reorientate that around. And now I want to bring in some context to that. So I'm going to start bringing back some parts that are within the bounding box of that. So here very quickly, I've been able to find the part in question and isolate it and pull up parts around it that are in context to it. And so in this example, I might imagine that I need some spacing and some dimensional considerations given. We might need some more distance in here to be able to handle the heavier engine. We might also put in here that we need a thicker wire diameter, as indicated here. And so I might just add that pin in there as well. And so now you can see that once I have added that comment and I found the view that I want, I've automatically created now this snapshot over here on the left-hand side. And once I've got a couple different snapshots that I would like to put together, I can simply come in and click a few of these and now create a story. And now I'm brought into this. I can quickly name this story whatever I would like to, and add a description. And I've got that in there. Now, from a security standpoint, we understand that a lot of companies have very sensitive information that they don't want getting into wrong hands. And being a cloud-based software and providing a platform where images such as this are simply rendered down to your device, nothing is being cached down to your device or your collaborator's device. It is a rendered image that enables users to be able to access the digital twin. And further, if I want to come in here, I can, as default, start unlocking certain activities that I want to enable my collaborators to do. So, for example, if I'm comfortable that there's no IP in this certain snapshot, I might enable them to perform measurement on that snapshot. Likewise, if I'm okay for them to do a cross-section capability in there. But this snapshot here, you know, it includes a lot of information that I really don't want them to be able to further interact with and perhaps uncover any of my IP. And so I'm going to leave that the way it is, locking them down from doing any measurement, any cross-sectioning, et cetera. For example, also, if we want to be able to enable a collaborator to pull out geometry so that they're able to pull that into their CAD system and perform any type of analysis, perhaps a redesign, propose some changes back, I can come in here and enable export. And now when a collaborator accesses this snapshot, they'll see this export button, and they're able to now export out either a JT or a step file format to be able to pull into their system to be able to perform any changes that they need to. And so let's just imagine here I've got a story about this supercar, and I've got some issues here around my my brake. And I've come in here and I've denoted some issues where we've got perhaps some overlap, as noted in here. Once we're in the story, we're able to, as you can see over here on the right-hand side, actually attach a photo, perhaps of something that's taken out in the field. Perhaps you want to attach work instructions to that. We're also able now within the story to bring in some at mentioning. So if we want to specifically tag a collaborator and bring them into the story, we're able to do so. So again, to be able to get that out to your collaborators now, you're able to just simply share this story. And if I just share this now with a demo account of mine, and I'm going to hit done. Now, here within a few minutes, your collaborators should be able to then get that, get an email notification within their inbox and be notified that they've got a story that they would like to collaborate on. And here I'll just now share this view. Just a second. All right, so hopefully you should be able to see a little pop-up screen. I've got my iPad, and you're able to see now that I've received this story, and I'm able to now open it. And again, I'm on an iPad with literally no software, no really computing power to be able to do anything with it, but I'm still able to access the digital twin. I'm able to come in here and perhaps reply back as a comment. Yes, so, okay, I see the issue. And I'm going to hit submit on that. And then back here in the other snapshot I've got is the ability now for me to come back in and see that reply. So we've been able to go back and forth, let's just imagine, and we've resolved our issues. We've been able to, as a collaborator, perhaps come in here and update or add as an attachment a revised model, and that's generated now a new revision to this supercar. You'll see here that I've got this little red dot, which is indicating to me that my geometry in this story has been updated and that there's new geometry available. And so instead of me having to now go back and retake snapshots, recompile a story, and resend that out, I can simply come in here and click Get Latest Snapshots. And now these snapshots will update to the latest revision of that. And if I were to come in here now to that, you'll see that we've been able to reflect the indexed over break disk, thereby taking care of the issue that we had. Not only am I able to enact that update here on my device, but any of my collaborators, if I revert back now to this mobile device here, my laptop, you'll be able to see now that here on my story as well, as me being a collaborator, I've got the updated geometry. And so hopefully this has been enlightening for our audience members to see just how practical Vertex is making the digital twin collaboration and being able to get information out to other functional areas that perhaps need to see that information, need to view that information, need to align it with their data business decisions. So I think at this time, we'll open it up for questions.
Thank you, John. We do have a couple of questions to ask. One I want to clarify is that this is a cloud-based cloud-based organized software. So I think you said this. I just want to be sure that we clarify this. You don't really have to download a piece of software onto your computer. You can use everything through the cloud interface. Is that correct?
Yes, that's correct. And yeah, there's so two things being cloud-based here is that it enables access to information without the need for it to be cached down or downloaded onto your device. And so that also helps from a security standpoint, knowing that whether it be a potential customer, whether it be in a supplier, whether it be in somebody else outside of your organization, that they're able to view this information in a secure way, and they're only able to actually download the information onto their device if you've enabled them to do that. Prior to that, all the experience that they're going to get is the ability to be able to view without being able to cache down anything to their device.
Fascinating. Well, we have, like I said, we have received several questions from the audience, and we'll begin addressing them now. We will be able to stretch a bit beyond the top of the hour if need be, and you're welcome to stay with us. If you can't, remember that you can revisit this webinar anytime you wish after 4 p.m. Eastern today. And should we have to wrap up things before John or I can respond to all the questions, any unanswered questions will be answered by email. So let's go on to our first question. How is licensing handled to collaborate with outside vendors and suppliers? And I think that gets back into the whole notion of your architecture.
Yeah, absolutely. That's a great question. First and foremost, if we come back to our positioning statement where we really enable data to be presented in a way that others are able to get to it in a secure way, we realize that companies perhaps who've subscribed to the Vertex platform may not be collaborating with other parties who have as well. And so what you just saw me do from a story share standpoint is totally free. So if I'm company A and I want to put together a story to collaborate with company B, which might be my supplier, or it might be a customer, or it might be a dealer in my dealer network, I'm still able to send them this story, and they're able to access that story and collaborate in that story and perform those functions that you just saw me do within that story on my mobile device without any barriers to being able to get set up in any type of page structure.
Okay. The next question, which is sort of related to this, but is more about security, is cloud-based tools get scrutinized for security by my IT team. How are files handled and stored? And I know you've kind of mentioned this before, but I think it needs a little more detail here to talk about security.
Yeah, absolutely. So if I were to come back here to this screen where we've got it here, either by a manual import or, again, by the API as it's loaded into Vertex, we'll take that 3D model and we'll use it to then what we call break it into many different pieces and then scatter it across all of the parallel servers that we need to in order to be able to handle that data. Once that data has been disseminated across those parallel servers, each one of those pieces of data, by the way, gets encrypted. It's encrypted both in rest and in transit. We then blow away that model that we use to perform that tessellation. So we essentially blow away that record. There's never, ever going to be a complete file held in the cloud of that information, if that makes sense. And so then when a user wants to pull up this model, so for example, if I come in here and I pull up this supercar, essentially then what it's doing is it's compiling all of those pieces across those multiple servers and rendering them into this image. And Vertex is the only one, again, you can kind of view it as, we hold the key. We're the only ones that hold the key for pulling this information back together again. So for example, if someone were to break into an Amazon, server farm and they walk out with a server, they by luck, by chance, break into that server and decrypt a piece of it, they're only going to get, perhaps a very small piece of that model with no frame of context, no frame of reference around it. And so, again, your information, customers' information is never held in its entirety in the Vertex platform.
That makes sense. John, do you mind if we change topics here just a little bit and talk about the organization? What I've seen here is an amazing tool, I think, for collaboration. and for breaking down silos. But, do organizations do they need to think about changing themselves? And a good example of what I have in mind here is that when computers came along, there was this organization called the IT department that was formed. And you couldn't imagine an IT department existing in 1950 or even 1940, and yet now they're central parts of every part of any organization that exists. Do organizations need to think about that kind of reorganization when it comes to adopting digital twin, even with tools like yours?
I think when we think about organizations and how they might need to change, we need to think probably more along the lines of workflows and challenging the status quo. And certainly, I would say the resident thought that we have to rely on hardware, that we have to rely on expensive software and complex software in order to be able to do what we need. When we think about an organization and their workflows, we generally tend to run into the status quo, right? We've always done it. It's taken me 20 minutes to access a digital twin, and that's just the way it is. And I've always had to spend whatever amount of time, whether it be 30 minutes, an hour. We've actually heard cases where companies might spend upwards of 18 to 20 hours a week just prepping material, prepping data, transforming it, stripping it out, putting it in formats that other companies are able and other parties are able to consume. But yet that's the status quo. And so that's where, from an organizational and a mindset standpoint, it's understanding that, those things aren't needed anymore. We also don't need to rely on computing power. We also don't need to rely on hardware. We don't need to rely on people being co-located anymore. I mean, we can access this information literally anywhere. And if we're thinking specifically about IT departments, at this point in time in particular, many IT departments, I got to imagine, have been thrown into a state of chaos, if you will, trying to figure out, how do I keep the organization connected? How do I keep the organization moving forward? How do I ensure security through all of this, with people working from home, with people perhaps in disparate locations now? How do I ensure the security of my data, as well as the ability for the company to be able to pass this data around? And so from that standpoint, I would say Vertex is providing the opportunity for organizations and companies to streamline those workflows and be smarter about how they work.
Okay. Well, I think that's about all the time we have for today. Remember that you can revisit this webinar anytime you wish after 4 p.m. Eastern today, and feel free to share this link with anyone you wish. As always, SME and SME Media can help you keep abreast of developments in automation, robotics, and smart manufacturing on our website, sme.org/latest-news, latest-news, I should say. And also in these times, I think you'll find our podcast useful, available from any podcast app as Advanced Manufacturing Now or at sme.org/SME-media/podcast. And be sure to review our webinar schedule for the rest of the year, available at the SME website and the Manufacturing Resource Center. Thanks a lot, John, for joining us today. I think it was an extremely valuable and informative webinar.
Yeah, thank you for having us on, Bruce. Appreciate it.
And thank you, listeners, for joining us for this SME Media webinar. We hope you found it as informative as I did.